So I took a little time to put the amplifier board together. That's a shot of the back side of it. The lighting's not too good on this bench, but it turned out pretty good. There's a shot of the front of it, and there's all those black wires there are the heaters. So I was, like I said in an earlier episode, I'm running the heaters on top to try and minimize noise injection. So in the current setup here, I've got the power supply board also wired up. I did some experiments with the voltage divider circuit on here, and I came up with a good working setup. Nice current, nice bias current. The tube push-pull amplifier is idling at about 160 milliamps at 250 volts, which is, a lot. Right now we're pulling about 700 milliamps at 120 volts, so that's a significant amount of heat, and this thing is warming the room nicely. I've got the this signal generator here is generating a sine wave input, and I'm dumping the load into my P005 signal analyzer. That's something I put together. I may have to do an episode on what that thing is. And on the scope, the yellow trace is the output. I'm locking on the channel 2. Channel 2 blue is the input. Now let's just switch over to trigger on channel 1. It's a little bit easier that way, and that way I don't really have to care about channel 2 so much. So I'm gonna put this up to like 5 volts per division and start increasing the input voltage, and you can see that it's starting to distort right around there. Right around 5 volts peak to 19 volts peak to peak, and we're looking at about just under 6.5 volts RMS, and the input going into the phase splitter is 2.5 volts RMS. In terms of voltages, this little thing here is measuring B++, which is the voltage to the phase splitter. This is measuring my B+, which is currently sitting at 151 volts. And this is monitoring my heater voltage, which should be 6.6 volts, 6.3 volts, around that. 6.3 actually. So that's a little over voltage. This is a pretty hefty transformer, and it can deliver a lot of amps, and it's actually a little bit overkill for this tube amp. I could have gone with one with a slightly lower output voltage. There we go. So there's my B plus voltage there, 255 volts. I didn't have it connected and it was floating. So let's measure the cathode bias here. These are 300 ohm resistors and they're 1%, so they're pretty precise. I measured them. They're all within 0.1 ohms of one another. So measuring across here, we get 11.3 volts. So the grid 1 of the tube is hovering around minus 11.3 volts bias. And ideal here would be around 12 volts. I've noticed that when it's running fairly early in the warm-up cycle, it is hovering around 12. And if we go to the measurements here, if we look at 12 volts bias, we can see that our cathode current is around 40 milliamps for that tube. which gives us a total of hovering around 160 milliamps for the entire push-pull circuit. From the testing, I finalized on the voltage divider circuit. So I'm running two 15-watt resistors here. These are both 15-watt. So from the push-pull diodes, 100 ohms, 15 watts, going to 47 microfarad, 450 volt. This is to soften the blow a bit on the capacitor charging to help the transformer a little bit when it's first starting up, because these diodes are just going to start right off the center. They don't need warming up. The choke's the 2 Henry choke at 200 milliamps. It's a Hammond 157R. And then it goes to another capacitor, so we have a pi network filter here. This is 330 ohms to bring the voltage down to our B+, which is currently at 250 volts. Then we go through a 6.8K to get our B++ for the phase splitter, and that's around 200 volts, a little less right now. And then finally we have a 51K here. This resistor here is used to bleed the capacitors down on power off, and that's a pretty good value. It's pretty quick on bleeding down the resistors, and it doesn't heat up very much, so it's not wasting too much power. I got the power supply module out. I did some fitting inside of the chassis, and this resistor, the way it's mounted here, is too close to the tube base board where all of the tubes are mounted in. So I'm going to move it over so it's more parallel here, and just shuffle some things around. I'll probably put these resistors also over into the back turret board here, and clean it up a little bit. I don't really necessarily need to do all this fussiness about the lead length. I have more than enough here, but no sense being lazy. I'll just clean that terminal up. Right, so I should be able to move it. I don't typically do a lot of shots of me working on moving stuff around because I don't think it's all that useful, but you know, if somebody thinks it's worth doing and shooting more of these, you know, you can chip up and say something. So I'm probably just move it in a little bit closer like that. So I need to drill some new holes. I picked these up a little while ago off of Amazon. It's a combination drill and tap for metric size threads, and I have a whole host of them. I think this is an M3, and they're really super handy. You have to be a little bit cautious, especially drilling into aluminum, because you don't want the threads to gall up and then mess the threads. Also in the drill, you have to keep the drill really steady to prevent wallering out the hole while you're tapping it. Well, the way I do these is I will locate the part, and then I will just mark one side of it, just using the tap, the drill part of the tap, to start the hole. And then I can finish the hole at that point. Just off camera, I picked up a backing board to drill into. I don't like drilling into the mat. And just removed a couple of resistors just to clean up the area. It makes it easier to work on. So I've marked the hole. I just used the drill tap as a way of getting a starting hole in the part, and then I'm just going to continue on with the drill. Hold on to it. So I'm gonna put it over a hole that I have, and then tap. Let's see if I can get into the shot. There we go. And the hole's tapped. So you just deburr these. You can either use a drill bit, which is what I used to use, or I just got this hand deburring tool. It's pretty handy. It's not fantastically good, but it seems to do a good enough job that I don't have to usually worry about it too much. Although the soft aluminum, it doesn't really do an excellent job on soft aluminum. Not as good as I would like. So we are good to go there. Let's just put a is it 3mm, I believe, socket cap screw in. That'll hold it in place. I don't over tighten these because the soft aluminum doesn't really hold a thread that well. Just a little tweak, enough to hold it in place. Prior to final positioning these, I'll put a little bit of heatsink compound underneath them, and this plate here, which supports the transformers, will also act as a heatsink for these large 15-watt resistors. And then I'm going to use a little of this material called a sill pad, and I'll put a little bit of material between this board and the top of the chassis, and that way the top of the chassis then becomes an extension of this heatsink, because the sill pad is thermally conductive, and it's used as a gap filler in when you're doing solutions that are passively cooled, or you need to do a thermal transfer without having a low resistance path. And then the transformers on top act as the final layer of heat sinks. So get the second hole started. Okay. Move this out of the way. And drill the next hole. Likes to take off on you. Okay. So there's our holes tapped. That one might be a little bit on the weak side because it's really close to an old hole. I'm not really concerned about that too much. Oh, I can't get in there. Just want to clean up the hole on the top side so it doesn't impede the surface to surface mating of the resistor. Okay. So the second hole is drilled. The second cap screw in there, and that's that. Don't over torque it. Now we can put this, so this is the cap on the other side of the pie filter, the choke. So there is no wire per se going between this terminal and this terminal. What's going in here is the large choke that we're using as part of the pie filter. So the first cap in the filter is here, then the choke, then the second half of the filter is here. What I'm going to do is on this one I'm going to use this as the other side of this filter. So we kind of have a two-stage pie filter here where the first stage is inductive and the second stage is resistive. That should help to clean up the AC ripple on the DC power supply nicely. So let me do a jump here and I'll get back to the video once I've got more of the circuit laid out where I want to put the final two resistors. I'm just putting the final resistor on, and I wanted to sort of show a neat little trick for insulating high voltage wires. I got this stuff off of I think it was an eBay, or no, not an eBay, but a Amazon link, and it's just a tool thing or something like that. But this stuff is silicon covered wire. The wire is kind of a bit crap. It's very fine, not very good for point-to-point wiring. But the silicon on this is actually pretty nice because it's it should give you a fairly high voltage rating insulation, and it's really super easy to cut. You just do a quick measurement of how much you need, and you just take side cutters and boop, just cut it off like that. Sometimes you get some of that fine wire left in the insulation. Just take it out, make sure it's not in there. Slips on over the wire and gives you a nice insulator. It's not too expensive. It's a little bit cheaper than buying the Teflon covering wire. And the other nice thing about this is because it's silicone, it's flexible, it'll expand. So if you have a larger wire that you need to get something through, you can usually, with a little bit of effort, squish it on there. Versus Teflon, which is a bit more unforgiving and it won't really let you do that. fold this around. And this final resistor here is the bleeder resistor. So its purpose in life is to make sure that the capacitors discharge fairly quickly when the power is turned off, as a safety feature. It doesn't really need to be there for the audio circuit. It's there as a safety feature for the system. Because the last thing you want to do is have 200, 300 volts left charged in the capacitors. You get a pretty nasty shock if you're working on it, or if you inadvertently touch it when you think it's safe. So that's the final layout, and I'll try to include a shot where I give a little bit more of explanation of why I made this slight edit to the circuit. And one final thing I have to put in here is a ground wire to here. So here I've got the tube circuit already mounted in the box. It's a bit of a tough fit because you have to loosen the side ears here in order to get them in. But once in the box, you can just simply tighten them back up again, and it's ready for final fitting. So that's not really going to come out of the box now, and I can move it around inside the box and get its location correct. And there we go. Okay, so this board here, the power supply board, will go in right about there. Oops, wrong way around. And there we go. So there's the board. There's the two boards in the relationship. And now we have a nice clearance there. Oops, nice clearance there. So we don't have to worry about high voltage arcing, which is always a good thing. The power supply for the preamp board will go in here, and it'll be a little bit further up. And then the choke for the power supply will go in here, and there's enough clearance there, it shouldn't be an issue. And then on the back, the AC input here with its power on-off switch and the fuse, it's all one modular unit. So it will go in here and be roughly here. It doesn't mount to the chassis though, because there's like a 1/4 inch or so of wood trim around this. So this will actually go into that wood trim, and it'll reset slightly into the wood trim. I'll put a bit of a mortise in to the wood to allow this to set in nicely. And on the other side here, we're going to have the left and right channel line inputs and some line outputs that allow this to be daisy chained in prior to it going into the main amplifier. So the audio source coming in is line in, it goes in, gets looped back out again, and this kind of taps off those two inputs. This here is designed to fit in here, and it will actually go in a little bit lower. That's one of the things I'm going to have to jury rig a little bit, because these pots will have to, they go further forward, like out of the shot. They're a little bit further forward like that, but when this goes in, it's going to have to sort of play nicely with the circuit here. So I may have to move some wires around I kind of placed the tubes initially so that the two pots, the volume control and the boost cut base, would go in between the tubes. But this also has to play nicely with all the wiring and other things going in here. So I may have to move some components around. This is all part of the jiggly process of getting all the work together and not short out. The other choice I can have is also to move the board a little bit forward. I have some room in here, so I could move it a little bit further forward, although I don't want to go too much. That'll give me a little bit more room to get the pots in on the front. I did some initial testing, and just having this below the circuit surface, I should have enough room in here to get all this in. Locating the holes is going to be very tricky. I want to get the turrets as close to the surface as I can. There's no real danger. There's no high voltages on any of these, so I'm not really worried too much about them shorting against base. So anyway, that gives you a kind of a preview of what it's going to look like. Let's see if I can show it. And everything's looking pretty good so far. It's all fitting together nicely. So hopefully shortly we can start drilling holes in the chassis and getting this finalized. So I've taken a little bit of time, and I've put the amp together, wired it together as a test bench. It's out of the box, of course. So we have the power supply, the tube board where all the tubes are mounted. In the back there is the low voltage power supply, and then this is the preamp board, and this is the bass boost cut, and this is the volume. So I'll turn the volume down to start it. I've got the output of I've also got the power transformer mounted already, and this is the output transformer. They're mounted onto the plate to give it a little bit of cooling, to keep it somewhat cool. It gets a little hot with all of the power being sunk into the board as heat from the power resistors. I'm looking at about 116, 117 volts at 700 milliamps. And as I said, the output is going into my signal analyzer just as a way of hooking it up to the speakers, because I can swap it between a dummy load and a live speaker test. And I've borrowed one of my speakers. This is one of my Fluence speakers from my tube stereo, and I'm using it as a subwoofer speaker. It's not really designed to be a subwoofer, but it can handle the power a little bit better than that cobbled together speaker that I had before in the last clip. And for music, I'm going to be using this Bad Snacks City Night Lights from No Copyright Music. Hopefully I won't get any hits. So I will start the music now, and then we can go over to the volume control and start cranking it up. So that's the midpoint in the boost cut. And there we have the sound. So I'm going to unclip my lapel mic, and I'm going to put it up near the speaker, and then I'm going to mess around with the boost cut, and I'm going to mess around with the volume control, and we'll see what it sounds like. I can't drive it too much because this thing's just not really designed to run as a subwoofer. that's with the boost cut at the full cut, so that's minimum bass. That's the midpoint. And that's with the full boost output. Bring it back to the midpoint. So it sounds pretty good. Pretty happy with the way that the boost cut is working. This is a line level input, so it's only 100 millivolts on the left and right channel, and so it's not, you know, as much as it could come from another preamp. Having said that, I mean, even at 100 millivolts, I've got the for the most part, this is the trimmer for the final stage. So this is the final output stage amplifier. This is a trimmer, and this here is going to the phase splitter tube. So I can actually tweak it a little bit here. If the signal level coming in is more than 100 millivolts, I can turn this down a little bit. Impressions on the noise, things like 60 hertz hum, 120 hertz hum. I'm not really hearing any noticeable hum at all. I have to put my ear right to the speaker to hear any 60 hertz at all. And I haven't even hooked up the balance circuit for the 6.3 volt heater yet, so this is looking pretty good so far. Really excellent noise, low noise output from 60 hertz and 120 hertz. Very happy with that. So next steps will be to disassemble the wiring, do more dry fitting in the box, cut the holes for the box, get these components inside the box, and then once the box is assembled, we'll do some more sound testing. We'll run it through some sweep tests and see what the frequency profile looks like at the different boost cut settings. And maybe at that point in time, maybe a couple of weeks, or worst case, maybe a month down the road, I should have a new subwoofer speaker that I can pair up with this that will work a bit better than the Fluence speaker I was using for testing. So I'm going to wrap it up here. Hoping everybody is doing okay, and pretty excited to see how this is going to turn out in the box. Get to do a little bit of woodworking to put the trim on the box, and then of course we have to punch lots of holes in our pretty little box and hopefully not destroy it, because I really don't want to buy another one. So I'm going to wrap it up at this point, and we'll just take it from here, see how it goes. Bye for now.